Okay, so now here you have the second lecture in AspectJ software development. We'll start with some slides and some discussion, but very soon we will get to Eclipse to try some code, and the whole lecture will be more like trying and observing what happens when you apply different aspects and how can we use them. Actually, the different constructs between the aspects. For the beginning, already at the first lecture, you might have observed that in aspect-oriented programming, you affect a program in certain points. Everybody laughs when I say that these are well-defined points in program execution. Because it sounds like, well, all the points in the program execution might be well-defined, or what does it mean? So, it means that you can specify them. You can specify them and select them out. So these are distinct events when a method is called, when it starts being executed, and even if you take it completely in object-oriented programming, there is when you apply polymorphism. At one point, you make a call, but then the exact method body is selected based on the exact type of the object. So these are the things that we might consider as joint points, as points where we can join some other functionality. We do not, so far at least, although there are some attempts, and especially in languages, dynamic languages, interpreted languages, there are attempts to directly work with. In a way, you can do this, to add functionality and program as the program runs, as it's being executed. But mostly we program and then execute that program, or with compilation process or without it. But the thing is that even when you are able to affect kind of a live execution of a program, you do this by adding some code, and this code is kind of a prescription of what has to be done, not exactly the thing that is being executed. Yes, so we work with some perception of this and try to manipulate things by prescribing this in source code. And the same thing is with joint points. You do not work directly with joint points. You work with what we might call a shadow of that joint point. Shadow in the source code. So, dobrý deň, vítajte. Pozor na kameru. We actually have some constructs how to affect these joint points. Or now you're in a position because you are not, you do not know much about AspectJ. You know some things, but you don't care very much about it. So imagine you are in a position to design your own aspect-oriented programming language. So you know now what is it about. The question is, if you would be proposing an aspect-oriented language capturing, or what kinds of joint points would it enable? I named some of them, but you might have some other ideas. So what do one thing is that we might think that whatever there is, let's be able to capture it. The thing is that we might not recall at the moment all the things, but the question is more about what do you find important to be captured. What would you like to be able to capture? So
maybe some changes of values of variables. Maybe if I want to debug my code, then I wanna see these changes, how these variables
so
change in time.
changes of variables. Okay. Come on, it will dry out. What else? We may add, or I don't even have to put this there. Method calls, or let's say method calls. And I mentioned method execution. We might even have this. What is the exact name? This mechanism that might be specific to C++. The mechanism it's kind of a table where you actually that resolves those polymorphic calls, like when you have overriding. I don't know, can we say that fetching method body or something like this? The moment I forgot. I think that there is some expression for this kind of commonly used. What else? Have these variables. These are you meant local variables, or
Yeah, this can be also class variables and also some.
so also attributes. So.
Declaration of new variables.
Declaring new variables. So. It's interesting. Anything else?
Maybe also declaring new functions. Maybe also declaring new functions.
Functions. Okay. What else? If you go deeper in control structures, we might like to we don't have numbered lines normally in modern programming languages. Numbered program lines like like some time ago I mentioned this in software modeling yesterday, that in BASIC programming language, like the old versions of BASIC for home computers, the programs were like have this line number like 10 and then print something and whatever, then 20, 30 and so on, and if you would like to modify your program, then you actually put some lines in between, so because you are consecutively just adding lines, so you could add I don't know, 15 or 11 or so. So you may intentionally make this space, so you could be addressing the exact program lines by this. But we do not, we cannot do this unless we make some labels. But normally we do not do this. Nevertheless, there are different constructions, control constructions that we can address. So you can have this for loop, or while, and you can say, okay, get me the first while in a certain method, or the second one, or you'll be using some iterator variables in these constructors, some variables, so like to set the condition here in while. So what type of that variable would be, or its value, or initial value, or whatever. So you could be kind of then specifying further this in order to narrow the scope of your selection. But it would be a bit tough, like to work with these things. So this sounds quite stable. Method calls, method execution. We distinguish here, as I said, between method call and method execution because you call it somewhere and it is being executed actually elsewhere because it belongs to some other object. And this mechanism as well for polymorphic calls and or overridden methods. And you mentioned here these changes of attributes and variables. So setting. How about reading? This is also a way to access them. So when you access an attribute, local variables are kind of not that stable, but you could imagine working with them as well. And declaring new variables, new functions. What does it mean? Okay, to declare a new variable, it means we would like in some languages we do not do this. It's kind of dynamically devised from the use of that variable. But in some languages like Java, you need to declare or define what the variable is, what type it is, and typically you do this at the beginning of your at the beginning of your method. What does it mean to declare new functions? I don't know, Dusan, you said this?
For example, if we were to specify its asynchronous function, so some new types.
Okay, in some languages you can do this, and that might be applicable as well. So I never thought of this previously. So we could have it depends on a language. So that's certainly a thing that we might conclude from this. And
Also, if I can add,
yes.
you can declare what type of return what would that function return type specific
return value.
You can declare a specific type that function returns.
And what type it is.
For example,
But actually you can operate for this specific
yes.
for declaring new functions. Okay, maybe, but also for the functions or methods that are already there, you might capture the return value, or this is the point when you may capture when your function is returning a value, or returning or ending, simply. And some methods or functions return a value at that point, some do not. And if they do, you can capture that value. And you can decide, you can then have a mechanism to decide whether to capture it or what to do it based on its type or whatever. You can capture the point, all the join points where a return value is of a certain type. But we are coming to something different here, because we are talking now exactly about the points in the program execution that you would like to capture, not about their features, characteristics. So for AspectJ, well, we missed some of the exposed join points in AspectJ because AspectJ does not cover all possible join points in Java. So we missed this initialization. Java is very kind of elaborated on initialization, and there you might not be completely aware of this, but before even when loading a class and when an object is being created, there are at least 3 levels of initialization there. So AspectJ can work with all of them and capture them, and you can affect what happens even upon loading your class, because not the classes are not loaded at once; they are loaded as needed. There is even like when AspectJ adds this another level of constructs called advice, which actually affect join points. So these become another kind of join point you might like to interfere with. So advice execution. So this is not a Java thing, but an AspectJ thing. And we had these methods. We forgot about constructors, kind of special methods to say. Field access, exception handling. If your language supports exception, then you might also like to capture exceptions and do some things about it. But this is not exactly like this. And we are coming to the point of how to work with join points. So you do not. You can say, okay, I want to catch a specific call of a method, but as I mentioned here, or actually as we started analyzing the nature of returning from methods, and we became aware that methods return different values of different types. So we came to an idea, at least me, that it would be nice to be able to capture all the method calls that return a value of a certain type, or that return a certain value. So this is kind of a not just one call, but all calls. So we work with sets, even when we capture a particular attribute and it being accessed for reading or for writing. Even then, this can be perceived as a set of one. So there's one join point there, and it's a set of join points. It could have been kind of several join points. So the specifiers that we use to capture join points in AspectJ. So we might think think of some other specifiers are roughly like this. So these kind of are very close to this method and constructor calls are very close, like just exactly follow the idea of capturing a particular join point. However, this one, control flow. You might capture control flow. What does it mean? When you say control flow in your program, what does it cover? So then you have a sequence diagram, something like this. So there comes some call, and this is kind of method M, and then there are certain calls like this, and there's another object like this, and it may be kind of like this and so on, but these arrows should be closed because okay, I think of asynchronous calls, but I thought of synchronous calls. So you start with some method M, and you can look at how, I don't know, X, Y, Z or whatever, how it looks, how the overall sequence of calls looks like, and this is a control flow. So if you say give me a control flow of method M, then it might look like this. Of course, if there are some conditional expressions or some loops or whatever that changes control, it might be different each time. So it's a kind of a dynamic thing. And in AspectJ, you can capture control flow. It means, okay, as I said, we are capturing rather sets of join points. So when you capture control flow, it means you capture a set of all join points that are there. So all these calls there. But furthermore, because we capture also field access. Fields are actually attributes in Java parlance. Field access, reading and writing, both. Then in that control flow, you will have also such join points. So all kinds of join points that you're capable of capturing, which we mentioned here, roughly. AspectJ will occur in capturing control flow. There is a construct for this called control flow. So C flow, like you would say something like this. C flow, give me C flow of, but it doesn't matter now the exact syntax, because you will need to specify the class and everything here, or at least say something like this in any class, or in class C. Let's say that this is class C, that this method belongs to. Could be better. So give me a control flow of this method, and it will give you this, plus what you typically do not see in sequence diagrams, also the attribute changes. Yes?
Why would we use this?
You'll see. There is an example, but does anyone find this attractive for some purposes?
Probably pipelines in machine learning for certain variables, how they change during these actions. I'm not sure, but is it possible? Because those pipelines call functions in some sequence, and if we pass some data set for its parsing, for its changes, for its transformations, we can observe its changes. So, for example,
why did this bother you? Because there is a huge number of joint points, and what to do with them?
I wasn't sure why would I use this, but now
yes,
I know.
you would get a bag of, or like a bag of set of different joint points, and what could you do with them? You could pick some interesting joint points. For example, you would like to capture this call here, but within the context of the execution of method M. So for this purpose, you would need to say how would you capture this call? Well, let's say this is a kind of, I don't know, X, Y, Z. So this is a Z class method. You saw this call Z call point cut that enables you to capture a particular call, but this will capture all calls to method Z in a program. If you would like to capture just this one, then you have this set and this set of all calls. How do you capture exactly this call, having these two sets?
You specify that C flow from M, and then you get this flow, and you take Z from it somehow.
Yes, but in terms of set operations.
They join with the call function which returns all of them, and then you join it together and get the Z from N.
But this is a set. So this is a set. Let's say S1, and this is set S2. So we are back to mathematics now. Intersection. Something like this. S1. Let's put it in S1 intersected with S2. And do you know that you can specify sets like by naming the values, or you can specify sets in mathematics by declaring the specifying the properties that the set elements should have. So something like A is a set of, I don't know the exact syntax now, but something like of all x, where x is less than where s all x belonging to the z set, which are integer values, where x is less than 5, something like this, roughly, yeah. That's it. So we are specifying our sets, but in terms of our programming language, and you can say that when you would have a set specified like this A and the set B, so you would say that both B could be that the same x from z, but x is greater than 0, so an intersection of these two sets if you would like to specify it in terms of these conditions, what would you need to do with that? X is less than 5 and greater than 0. An intersection, you can even name the elements that belong to this set that represent this intersection of these two sets.
1, 2, 3, 4.
Yeah, but what would you do if you would like to specify that, like using these conditions? What would you do to them? You need to join them somehow.
I would use if sentence.
No, like you have these logical operators.
So
And, or, yeah, and or.
Is it possible to use and or something from that with those point cuts? We can specify that we want to capture C flow of function m,
Exactly.
and stop
But
in the execution.
here
of that.
you would use and or.
And
And. So here you have it. This is and actually an intersection is and. If you'd like to join the sets like this, a union of two sets, then you would use or. Yeah, like the symbols are very similar, and there's reason for this. Exactly here, we would use between these two constructs and, but we write it like this, like double ampersand. That's the syntax. So this, so we don't need actually this and that. So we will just join this construct with this one using this AND operator. So you're working with sets of joint points, yes?
is it possible to initialize a point cut inside of other point cut? So we can do something like that, but without this AND operator.
A point cut
Inside other
of
point
another.
cut. So we initialize that we want to capture C flow, and inside
Yeah,
of that
exactly.
we initialize.
You're right. This is not correct at all. So this has to be something like this. So this was an approximation. So we could imagine the language working like this. but actually we are capturing a control flow within a call, within a particular call that happened somewhere or anywhere. So like this is call to see M like this thing here, like this.
And one more. Parenthesis. You.
Yes.
Sorry, third one.
This one and the third one like this.
Mhm.
Exactly. Because you want to capture this control flow of a particular call, and you could further restrict where this call is by using other point cuts, other point cuts, specifiers of joint points, because here you have these point cuts based on the lexical structure. So what's hidden behind this is that you can capture all the joint points occurring in a certain method, in a certain class, maybe even in a package, I'm not sure. These are lexical structure point cuts, but also you can do this dynamically. This is method and constructor, control flow based, execution object point cuts. This mysterious expression means that actually you can capture all the joint points that are related to a certain object that happen within this certain object, within all these things that are related to it. So you work gradually using these intersections. Sometimes you use unions to put together what you need. So if we look a bit at what we have here, so I think we can fairly quickly go through these things, because we came to those things that I wanted to explain to you through this discussion. So if we get back just simple point cuts, you can see that this is one of the simplest. So nothing very interesting here. So we are working still with this point example that we had previously, and we can capture the exact method called. This is demonstrated here. So not very interesting. What might be interesting is that what would we get as the output, because I might have this. Let's see. I'm in this in-access monitoring, but I have this range control as well. I can close this project. I'm not sure what I'm executing. Example point and access point. This is let me see. What did I want to show you first? No, access monitoring. We don't need this access monitoring. Sorry, this is what we had previously. I would like to change to show you some things in range control 3. No. Range monitoring. use that example, I'm not sure. Oh yes, I forgot to open this default package because I put out of the default package this range control because I don't need it for this example. That's why I was confused by how can it be that I have just one file there. So this is actually point monitor, and this is what I wanted to show. So this one is not particularly interesting, but you can just observe this construct or this clause, this join point. So we do not capture anything particularly interesting, but we will have an interesting output. So we will see what we will get by this by executing this example. Yeah, and then there are several calls to this because there are several things that happen which call this setX method. So what do we get is the reports like this. So roughly this is something that you can from which you can devise the nature of the join point that you captured, and you can devise when it happened. So this is by this we know this is before piece of the device, and we see that we capture this call to this setX method. Nothing unexpected. So we are actually this is kind of something similar to this variable that you have in Java that actually takes the value of the object being the reference or to the object being executed. But in AspectJ they decided to use this in order to not to provide you some reference because not very much use of that there would be, but to provide you with a description of the nature of the join point. So if we go further and check this point cut out, this is not a different point cut, but this is something that enables you to capture to cover several elements of your program based on the similarity of their of the names of those elements.
So it's something like pattern?
Something like that. Actually, you can use these wildcards to construct whatever you need. So here, you might guess that we will capture a bit more, and the output that we get will be a bit versatile. So we have this set X, set Y, and so on. And in between we have what the output of the program is. So if we go further like this, maybe this one is not. This one is not maybe very interesting to experiment with, but you can do even something like this, or you can do something like this. This is a bit not actually very different because you have integer here as we had before. So I think you can try the other ones on your own, but let me show you this one.
So it's
Yes.
on the left, that's
Yes.
the first one, means that we will capture any type of the function, returning type. Instead of
yes.
void.
Yeah, yeah.
Mhm.
Like you can, yeah, you can work with the returning type as well. So you also can specify the class name, or you can specify kind of what it should look like using this star asterisk wildcard. So you actually can combine these things as you wish, and sometimes this is useful because the naming conventions that you use in your program really do obey some rules, and often you need to kind of affect all the methods that do something similar, and this is reflected in their name because they mention this in their name. So this one is different. This is a lexical point cut that captures all the join points within the point class, or within any class that you specify. And if we would execute this, it would look like errors.
Parenthesis.
Yes, but here, actually I wanted to get rid of this. So, there's much more here. So these are actually all the join points that you get from the beginning. So as you can see, this is there is also static initialization, pre-initialization, and the actual initialization when you actually call the constructor. The execution of the constructor, or maybe this initialization is not really the constructor call. This is this one. It's not a call. It's being executed, and then the set method is called. No, the set is not the set method. Sorry, this is a set is related to setting a value of an attribute. So we do not observe the changes in local variables. We observe just changes in writing and reading, both writing and reading access to attributes. And you can see exactly which attribute is being affected and so on. So you can have a whole log of these events that happened in the lifespan of a class. And you would probably not be interested in working with the whole thing like this, but this becomes useful. For limiting the scope of your advice, your pieces of advice. So look at this. So let's keep this argument point cut and look at this. This is this control flow point cut that I mentioned, that we worked with here. Yeah, so the same thing but applied to this example, and we want to capture the whole control flow of this call of this method or methods set x and get x. Let's limit this to set x, and let's say that this is just points, so to make sure that we are capturing only one of them. And we are interested in this log, so to see what do we get in total, what does constitute this set. And if we execute this, we will get something like this, which is Stack Overflow. And the thing is that by capturing these aspects do not just observe things; they need to add a piece of themselves in order to enable you to observe and manipulate things. And in the end, the aspects themselves, or these pieces of advice, become join points within the execution of the program, and are being captured. And to capture this join point, then they add another instance of them, and then this happens recursively. So it never ends, and at one point the call stack is kind of becomes too long, and your program breaks. So what you need is to avoid capturing. You don't want to capture your own aspect. You want to capture just what was there. That was your intention. So you can use this within point cut to specify this. And it's not exactly an intersection just with this within point cut, because you actually do not want the join points that happen on the side of your aspect. Your aspect is called point monitor, just to remind you, it's here. And you don't want any of these join points produced by your aspect to be captured. So it looks fine, maybe even in plain English, like call this and not those. But in a way, it's what is it called in English? It's have intersection, union, and when you have like difference between two sets. I guess this is a correct expression. Something like when you have two sets A and B, and you want to have a difference. So we don't have this operator in AspectJ, but we have not. And you can transform this expression like it is A intersected with the negation of B. It's awkward, but it works. So not within point monitor, and if we execute this, you will see that there will be no stack overflow, and we'll be getting all the join points within the control flow of the, well, I wanted to limit this to point and set X, just to make sure that we know what we are working with. Otherwise, it will be mixed with, there's set and get. So we don't want this, and if we don't want this, then it's better to have it simpler. And let's execute it once more, and just have a quick look on what we have here. So it's smaller now because we don't have. We do not include that other method. So here you can see that all starts with this initial call, we distinguish between a call and execution, because the execution is something that happens, a call happens within some place. Okay, you can call your method in your own class, but it's very common to call a method in a different class. But the execution, it actually happens within the class where the method is situated, where it's placed. And you can distinguish between the two. In some occasions, this is very useful. Then we have this attribute set. Then this is the output of the program, and so on. So we can see that we can follow all these calls and followed by executions. We can get rid of the executions by further limiting this point cut, if we want, by further intersections, and get what we need. But typically, what we do is exactly this, and this we will see in the example that I will be showing to you shortly. We want to capture a particular call, so we do not want to analyze. Maybe you would if you would be programming some program monitor to monitor what's happening in some program and such things. Maybe this would be useful, but if you want to add some particular behavior to your program or affect some things, then this is not very useful to observe, to use these joint points to observe what happens and so on. But I'm using this just to show you what these constructs really do. So this is it. And then we skip this one, but let's go to this one first. So this is this point. Maybe I don't even have to execute it, but let's do this. Let's do it because this is a point cut very similar to within. And if you have a look at this, it's really like, if you recall, it started with initialization and so on. But in within, we had this static initialization and such things. So within captures things like in lexical terms. So whatever is defined within the scope of a particular class. Also, there is a within code that you can use on methods. So everything that happens within a method, and this will I'll be showing this to you in a moment. But this is a point cut which is it takes things dynamically. And it takes whatever happens between a particular object. So you are not limited or applying this to. You do not apply it to a class. You apply it to an object. And if you put it like this, then you apply it to all objects of the point class. But you can apply it to a particular object, and by applying to a particular object, you actually can capture that object and have it as a part of the context. Much similar to this point cut here, which works with arguments, but here is also applied to a type and not to a particular argument. So you can capture all the joint points in your program that whose argument type that have one argument of the integer type. So it's strange, but actually, in using this in intersection with other point cuts, you can get to what you want. So if you would apply this, then we will get again a bunch of. I will not do this, but you can try this out. You will get you will capture all the joint points wherever the argument type is integer. And this is for both set x and set y. I don't think we have other methods like this here. And this one is a bit kind of. I can leave it for the exercise, and we can discuss it the next time. Experimenting with or we will get maybe to this in the end of the lecture. Just I will mention it again because there might be some problems with point cuts that you can encounter, and then you have to analyze your point cuts and combine them in different way and see what went wrong and such things. So this is an exercise in that. So this is roughly it about the point cuts. But let's have a look at kind of more this is in general, speaking in general. But let's look at a particular example where we can utilize these point cuts. So let's get rid of this point monitor. And I can get rid of it by putting it out of the build path, exclude, and I want to include this one, range control. So we're back to range control. We stopped with this last time. We talked about how to control, how to monitor a point first, and then we talked about how to monitor it and check the actual values and such things, and then we came to an idea of limiting the coordinations that a point can take, and this is a continuation of this example. So the example is roughly the same with the point, but there is another thing I added. It's a shape that actually consists of points. So this is another class that utilizes the point object to define a particular geometrical shape. So it's for us it's nothing more than a list of points, and we can imagine that these points are like all connected in the order that they are like listed there, whatever. Nothing particularly interesting here for now, but this one, let me see. This in charge. So this is case 1. Oops. And I think I need to put this out like this. Okay, so let's focus on this. This shape, as it is common for shapes, can be moved around. So we know that we can change we can move a point by just changing its coordinates. But it is more effective if we could move the whole shape by a certain distance, then we move actually each of the points the same distance. So nothing very fancy about that. If we would have this shape class and shape objects, then we could imagine that our example would be could look like this. We could have some free points and we could have some shape points. Some points are part of the shape, some points are not. And we could move a shape like this, and we could move these individual points like this. The thing is that we might like to capture the moment of those individual points and follow this without any restrictions. So this is this first case. So if we would do this, we would capture everything. I think I don't even have to run this. We would capture set X calls within the point class, within this example class here, and within the shape class, limitlessly. So all of them. But if you would like to limit this to the shape class, so we would like to just to capture those points that belong to the shape class or to a shape object. So we will effectively we want to capture the moves of shapes and their particular points, and not those free points floating around. Then we can use this within point cut to limit the scope of these of this call point cut and this arguments point cut, which actually enabled us to capture the type of the argument and the exact value of the argument previously. So we discussed this previously, but now I add this within shape. The within shape point cut that enables us to capture only those points, calls to the set X method on only those points that belong to a shape object. So if I activate this also for in parallel for the y-axis, we can see, and if we execute this, we can see that we will not capture these free points, this free point here that we have, actually one of them. So we see that it remains unscrolled, like it remains, its coordinates remain the same. The shape that we had here was like 10, 10, 100, 100, and 1000, 1000. So the coordinates are being recalculated only for the shape, and these are being unaffected. If we get back to this exam, to this shape class, so check this one. Oh, it's fine. So if we get back to this shape class, and if we imagine that we are not satisfied by this move method for some reason, and we change it for something like this, so it's a bit artificial, but what I did is I introduced another level of interaction. So I'm not just moving points directly in this method move, I'm delegating this to move indirectly. 1, and I have this one, the second one. Okay, so the control flow is being a bit extended and becomes more complicated. This was kind of a really a flat control flow, so that enabled us to be happy with this previous this version that we use within shape, and we are happy we can capture whatever we need. Now, if we leave this advice and this point cut like this and execute this program, we will still capture what we need. Let me see. Shape. Yes, we are even happy now because nothing lexically it remained the same. Like even if we extended this scope, this control flow, we are still within the shape class, so we did not spoil anything yet. But if we complicate this further by doing something like this, because I need another class actually to get out of the lexical scope of this shape class. So I need this point mover class. So I introduce completely a different class, and I'm now no longer within the shape class when I do this. Move indirectly, but this move indirectly does this, calls point mover. So now, if we execute the example, it doesn't look good. I don't know why do I have 1300 here really now? Oh yes, because I moved this, because I added this 300. Okay, so it's not that I'm changing this 1000. So I added 300 and it remained 1300. So I missed a drawing point that I wanted to capture. So I created a certain point cut. It worked fine, and I relied on it for some time. And then one day, somebody came and changed the base code. The base code works actually the same way, like it. The behavior is the same, but they did some refactoring because somebody told them, okay, you should have another class for this because this is a different kind of operation, and it should be delegated to another class and something like this. Convince them to change the base code, and they changed it. I didn't even encounter the change in behavior as a kind of I'm responsible for this aspect, and somebody else might be responsible for the base code, and the things get spoiled or got spoiled. So this is something that might happen. Put this up. So the thing is that this can happen even if it's not your own code. So you suddenly forget about your aspect and you change the base code, so it doesn't even have to be somebody else to blame. And you can correct this, and maybe you should have used this from the beginning. You should have made your point cuts stronger, or your point cuts actually the two of them in parallel, the same. They are now analogs for x and y, the x and the y axis. So you should have used something else. You should have used control flow. And if you put control flow there, then it really does not. This is not limited to the lexical scope like within code. Sometimes we use for methods. So the lexical scope is kind of something useful for some occasions, but for some things it can break. And if we put it like this, then of course you can get it to work. So even if you would try this for the initial setting, it can handle that initial setting. It's much stronger. So this is something to consider when you work with your point cuts. So it's not that actually the first version of a point cut that you get to is the best one. So you can think of how to make it stronger. In fact, this is a problem that has been addressed in several papers, scientific papers. AspectJ is still a kind of a language that is being explored, and there are scientific papers around it. Previously, when it was considered more a scientific prototype, more discussion was there about AspectJ. And one of the topics is point cut fragility. How fragile your point cuts? How they break? Do they break? So point cut fragility. This point cut. This is kind of a legitimate topic if you would be interested in exploring AspectJ within your project. This might be something to look at. Maybe there are a few more things here. I don't know whether maybe just a quick note on this. We talked about so far about affecting behavior in existing classes. I think that here, I don't know who mentioned this, declaring new variables and new functions. Capturing these points is one thing, but imagine being able to do this, to declare, to introduce new attributes, to introduce new methods to your classes. If you do this, nothing will happen until you call them, but you can introduce also some behavior that actually puts them in function within some context. So AspectJ enables you to do something like this. This is an example taken from the AspectJ in action book by Ramnivas Ladat. This is just a class, so this is a class that represents an account. It's a simple idea of an account, might be a bit kind of, well, if we imagine an account, this account is a level for the bank clients, like sometimes we need objects like this, but banking systems are more like transaction logs than having a kind of a nice account class that actually maintains the value of the balance that a client has. But anyway, this is just a simple class that maintains this balance and account number, and you can credit it, you can debit, and there's this exception, sufficient balance exception. So nothing particularly challenging there. And you can have a derived class for for a savings account type. And what might be interesting is to look at this aspect that actually represents a business rule of introducing a minimum balance, which might be applicable for some banks and might be not applicable for some banks. So we can switch it on and off if it is in an aspect. And what it takes to introduce this minimum balance aspect is that we need to define what this minimum balance is, and we do this by introducing an attribute, not within this aspect, but within this account class. So we put there another variable. We are not following that variable, we are putting it there. We put there also a whole new method, get available balance. With these constructs, nothing really happens, because nobody uses them. Who will use them? Well, because we can create pieces of advice that utilize these elements in order to enforce this minimum balance rule. And one of them is to follow when this savings account is being set, because we want to affect only the savings accounts. Let's imagine that this is the case. So we capture this account, and this is how we use this point cut to capture the actual object that we want to affect. And we set, because we cannot do this, we do not want to do this in general for all classes. We want to do this per object, because this is a value that we set. And this is not a static attribute. And yes?
Is this code a part of Java class or AspectJ class?
This code is not a part of Java, of normal Java. This is AspectJ.
Yeah, but isn't it possible to achieve the same functionality by declaring a minimum balance variable or attribute?
Yes, within
the class.
like you can avoid whatever you need to do in AspectJ. You can do this in plain Java, but you will have this code within your normal Java code, like normal classes. So you will have to change the class.
Yeah, of course.
And now, if you do this, if you set the minimum balance rule as an aspect,
so we can use this class.
You can switch it on and switch it off, yeah.
Mm-hmm.
And you can implement different versions of this aspect for different clients. One client wants some behavior, the other one wants the other behavior, and this minimum balance is here set to a firm value, but you can even engage here some, I don't know, statistics of your client behavior, and then give him more or a higher or lower level minimum balance, or even no minimum balance. So for the clients that who you don't trust, then you will set a higher minimum balance for them, and for those who you trust, it may go all the way to zero, even be negative. I don't know.
So that function, for example, get available balance, can be called from an account object or from this aspect. How will we call
This function, get available balance, can be called from anywhere, even from Java classes.
So we
Put it
will
like
extend
this.
Java class, and so we can call this function from aspect from this Java class. It will be extended and added to the class. Yeah.
You can call it from an aspect, you can call it from a different aspect, and you can call it from a different class. If you introduce a method like this,
Yeah.
it really becomes a part of this account class. So if you would,
Okay.
yeah, you can even write normal Java code that utilizes this method. It suddenly is like there as if it was like really written in that class. It's not just within the scope of this aspect. It's completely like the class becomes modified. And this is the actual rule. So if it's a bit complicated because we capture this exception, so insufficient balance exception, we capture this execution of the debit method. We capture the context, the account. We capture the amount that is being taken out from the account, and then we check whether there is sufficient balance or whether there is no sufficient balance, and then we set here this like drawing or not drawing, or regulate this by drawing or not drawing is sufficient balance exception. That's why there is this draws construct. So the advice constructs are more or less like methods. So you can have these draw constructs, draws declarations also with them, like with normal Java methods. So if you want to work with exceptions, so if you want your advice, your piece of advice to draw an exception, you must declare it. So in a way, this is kind of we will leave this discussion of how far or how close this is to symmetrical aspect-oriented programming I mentioned in the first lecture, but in effect, by this you can see that how you can put in effect some business rules, and without affecting the core of your program. And you can modify a program for different clients like this, or maintain a set of aspects like this, and use whatever you need. This is a bit different behavior. You can use this construct, declare parents construct, in order to enforce implementing interfaces. So we will not cover everything today. We will cover this in different examples next time. But it's possible to do this. So there are even further, even more, even stranger things that you can do with aspects. But what is good to observe is that aspects not only modify program execution in joint points, as we observed, like by we capture joint points by point cuts, and modifications are expressed as advice. a piece of advice is executed before, after, or around a join point, but also aspects can add new elements and even inheritance. I'll introduce more examples the next time, particularly with inheritance, and these are called, some time ago these were called introductions, because we are introducing elements into classes, and now they are called, they ended up called intertype declarations. These do nothing to the behavior of a program, of course, but enable, like, set the things for like more sophisticated changes of the behavior. This is something that I never mentioned, and nobody asked. But if we think of what we saw up to now, we never made an instance of an aspect explicitly. This happens automatically, based on join points that occur in the program. There are aspect-oriented programming languages that require explicit aspect instantiation. So if you do not make an instance of your aspect, nothing really happens. This is a matter of choice. So the AspectJ community went this way, and the language ended up with automated instantiation of aspects. So roughly this is it for this lecture. Let's have a break. Or any immediate questions?
Ja bym chciał ospravedlniť, že som prišiel neskôr.
To vybavíme o chvíľku.